In this video, I'm going to go through another example of applying unit hydrographs to find a streamflow hydrograph. So in a previous video that I posted, we were given the following. We were given this rainfall information, and we were given this runoff information over here. And from that, we were able to create our unit hydrograph. So you can go back in my videos and find the video where we went through to find the unit hydrograph. But remember, again, the steps we used were to remove the base flow and then to figure out the total volume of runoff, convert that to a depth based on the area of the watershed, and then convert that to a depth of 1 centimeter in this case. And the last step was to find the duration of the storm, and we figured out based on the infiltration fee index method that it is a 2-hour storm. Okay, so our next step is we're going to take this unit hydrograph, which we know is for a 2-hour storm, and apply it to an observed storm to figure out how much runoff to expect in the stream. Okay, so here is the problem. We have excess rainfall shown here. So we have the first 2 hours, a total rainfall of 1.5 centimeters. This is already excess rainfall. So infiltration and other losses have already been accounted for. And then from 2 to 4 hours, we have 2.75 centimeters of rainfall. Again, rainfall excess. We have the same unit hydrograph. We're going to still assume a base flow of 15 cms, and we would like to figure out the total flow we can expect from this storm. So we're going to have to apply those two principles that I discussed in my previous video dealing with unit hydrographs. First, linearity, and second, superposition. A quick note, this is really important for us to be able to use our linearity and superposition, is that each of these excess rainfall increments has a duration equal to the unit hydrograph duration that we previously derived. Okay, so the only way that we can use this appropriately is to apply for that same duration. So my approach here is I'm going to call this 1.5 centimeters of rain that falls P1. So it's my first excess rainfall that has a duration of 2 hours. And I'm going to call this 2.75 P2. Okay. And then what I'm going to do is I'm going to multiply and create a table that is P1 times the unit hydrograph for each of the time steps of the unit hydrograph, and then P2 times that unit hydrograph. But I have to remember that I have to delay the start of the second unit hydrograph by the duration of the storm. Okay, so I'm going to create a table on the next page that fills this in for us. Okay, so in this first column, I am going to have the direct runoff for the 0 to 2 hour storm, that 1.5 centimeters. This is going to be P1, 1.5, times each of the ordinates. Okay, so what that's going to look like is at time 0, I have 0. At time 1 hour, I have 1.5 times 32.6, which is 48.9 cms. At time 3, I have 83.2 times 1.5, which is 124.8 cms. And I'm going to keep doing this, multiplying each of my unit hydrograph points by 1.5. So I'm going to pause it, fill that all in, and I encourage you to do the same. Okay, so there's that column all the way filled in. You'll notice that 12, 13, 14, and 15 are all 0. All right, so let's look at the next column. In this next column, I am going to have the runoff for the rainfall that falls from 2 to 4 hours. That's 2.75 centimeters. And so again, this is going to be P2 times my unit hydrograph, But let's talk about that lag. The storm is a 2-hour storm, so I am going to lag this by 2 hours. So that means that I'm going to take this 0 here and lag it by 2 hours. So it's going to show up in my table when time is 2. I'm going to have a 0 in this column. So now I'm going to go to the next column. I'm going to take 2.75. I'm going to write it out in here so you know what I'm doing. This is going to be 2.75 times 32.6, which is 89.7. Okay, and then this next one is going to be 2.75. That 2.75 again is P2 multiplied by 83.2, which is U sub 2, and this is 228.8 CMS. Okay, so I'm going to keep going down this column. So I'm going to pause it, fill it in, and I encourage you to do the same. Okay, so there is the unit hydrograph from that second 2-hour storm duration. It's one storm, but we're going to break it up. Okay, so the next thing I'm going to do is put in the total DRO. So I'm going to add those two columns up. Then I'm going to have the total runoff, in which case I'm going to have the total DRO plus the base flow. Okay. All right, so my total DRO, pretty simple to start. It's going to be 0, and therefore my total is 15. My total DRO at hour 1 is 48.9. So my total DRO for that time is 63.9. Okay. The next time I'm going to still only have the flow from that first duration, so it's going to be 124.8, and that total flow is going to be 139.8. At time 3, I have 164.1 plus 89.7, giving me a total flow of 253.8. That's a total DRO, and the total flow adding in is 268.8. Okay, so I'm going to go ahead, fill in the rest of this table. I encourage you to do the same, and then we'll look at all the numbers at the end. All right, so here is our hydrograph from that storm. Okay. Of course, it's really hard to visualize this by just looking at these values. So let's try and do a quick rough sketch of this. Okay, so we start at 15 CFS. After 1 hour, we're at 63.9, and we increase, and our max happens at 5 hours and is about 400. Okay, so it's going to look something like this, pop up, and then it takes a little bit longer to decrease in all the way back down to 15. So our hydrograph is going to look something like this, where we have flow and we have time. Okay, so as a water resource engineer, we would like to know after a storm comes, let's say we know that our flood capacity is here. So we want to know how long we have until our rivers flood. So we would want to know how long after the storm until this point occurs, and how long until the water starts receding, which is going to take until here. Okay, and we would also like to know the total volume that we have above that threshold, so we can figure out how far the flow is going to go into over the banks. All right, so this is one way one reason to use a unit hydrograph to estimate stream flow.